I want to find the nth term of the sequence below, starting with n equals 0. That's negative 9, 6, negative 2, 2/3, negative 4/9, etc. So if we notice the ratio here, we get 6 over negative 9, negative 2 over 6, 2/3 over negative 2, and negative 4/9 over 2/3. So all of these ratios are going to equal negative 2/3. Okay, so this is a geometric series with the ratio being negative 2/3. We're starting at n equals 0, so think of this as your 0th term. This is the first, second, etc. So you start at negative 9, and then you have to multiply by negative 2/3 to get to the next term. Now it's just a matter of figuring out what the exponent should be. So when n is 0, I want a sub 0 to be negative 9. Okay. When n is 1, I want it to be 6. So what should the exponent be here? Well, if I get negative 9 when n is 0, this thing should go away. Okay. So how does that go away? Well, you want to have an exponent of 0, which is n in that case. Now let's check for n equals 1. If I have n equals 1, I have negative 9 times negative 2/3 to the first power. The negatives are going to cancel. I have 9 times 2 is 18, over 3 is 6. Okay, so that works. So this would be our formula. Okay, next problem. So it could be shown that the improper integral, so from 0 to infinity, e to negative x sine of x, dx is equal to 1/2. Can we conclude that the sum, e to negative n sine of n, from n equals 0 to infinity, converges by the integral test? So we want to explain why. Well, for the integral test, there's a couple conditions that need to be met. First one, our function needs to be continuous. It has to be positive, and it has to be decreasing. Okay. Now, is e to the negative n over times sine of n continuous? Well, I can rewrite this as sine of n over e to the n. The only issue with a fraction is having the denominator equal to 0, which in this case, it's never equal to 0, right? E to the n is never equal to 0. And to convince you, you could just look at the graph. It's going to approach 0, and as n goes to negative infinity, but it's never 0. So there's no issues about continuity. So that's good. Is it positive? Well, the answer is no. Sine of n, we know sine of n oscillates between being positive, negative, etc. So it goes back and forth. So we can find n value when it's positive, or we can find an n value when it's negative. So this is not true. And because sine could, alternates between positive and negative, it's not always going to be decreasing. It could increase. So it could go from a negative value to a positive value, and that would show that it's increasing. So 2 out of the 3 conditions are not met, thus we cannot use the integral test.